Now my dear friends, we move into the kinetics of the second order reaction. Now when you talk about kinetics, it involves three parts. So we start with the first part, and that is the units of K. Now for that, I'll once again write down the expression for K, and that is K is equal to 1 upon AT into X upon A minus of X. Now X is concentration, A minus X is also concentration. So concentration and concentration gets cancelled. A is concentration and T is time. So therefore, the units I can write it down as concentration inverse and time inverse. This is the units. Okay. Now concentration is generally expressed in terms of moles per dm cube. And when you talk about time, it depends. It can be in seconds, minutes, hours, weeks, months, and so on. So let us assume that concentration is expressed in terms of moles per dm cube. So units of K will be moles per dm cube inverse. And suppose I assume that the time is expressed in seconds. So I write it down as second inverse. So this becomes the units of K. Okay, so I hope you have understood this very well. Once again I repeat, X is expressed in terms of concentration. A minus X is also in concentration. So concentration gets cancelled. So what remains is 1 upon concentration into time. So if I take it on the upside, so we have concentration inverse and time inverse. Concentration, if I assume it's expressed in moles per dm cube, so moles per dm cube inverse. If I assume that the time is expressed in seconds, so we have second inverse. Okay, this is about units of K. Now we go into the next part, and that is we talk about half time. Now half time, my dear friends, is denoted as T half. It is the time required for the initial concentration of the reactant to reduce to half of its value. So if you remember, we said that A is the initial concentration. All right, so this A is initial. The amount of reactant reacting is going to be X. So it means that when T is equal to T half, X will be equal to half of the initial concentration, that is A by 2. Whenever T is considered as what? T half. So at half time, the amount of the reactants which is remaining is the half of the initial concentration. So half of initial concentration is A by 2. Alright. So if we now substitute this in this rate law expression, what we have is K is equal to 1 upon AT. X is A by 2 divided by A minus of A by 2. So that is equal to 1 upon AT A by 2 divided by A by 2. Because my dear friends, A minus of A by 2 will give you A by 2. Alright. So A by 2 gets cancelled. So therefore we have K is equal to this has to be T half. So 1 upon A T half. And therefore we say T half is equal to, okay, T half will go on this side. So we have 1 upon AK. Okay. T half and K exchanging values. So T half इधर जाएगा, K इधर आएगा. तो हमें क्या मिलेगा एक्सप्रेशन? T half is equal to 1 upon AK. और इस तरीके से हम क्या लिखेंगे कि for a second order reaction, comma, the half time, that is T half, is inversely proportional to the initial concentration of the reactant. Okay, from this particular expression, we are going to write it down as T half is inversely proportional to A, because K is what? Constant. Okay, so this is very important. It is inversely proportional to the initial concentration of the reactant. So this is, my dear friends, about half time. I hope you have understood this very well. So my dear friends, under kinetic characteristics for the second order reaction, I explained you 2 points. Point number 1, units. Point number 2, and that is about the half time. The third point which we talk about is graphical representation. Graphical representation. So in that case, my dear friends, let us go back to the integrated equation. So where we had kt is equal to 1 upon a minus of x minus of 1 upon a. So I bring about some changes in this expression. 1 upon a minus of x is equal to ये minus 1 upon a जो राइट हैंड साइड में वो मैं उस साइड चेंज कर देता हूँ, तो मुझे क्या मिलेगा kt प्लस 1 upon a. ओके, अब इस इक्वेशन को अगर आप कंपेयर कीजिए with y is equal to mx plus c. What is y is equal to mx plus c? It is the equation of a straight line. Y axis है, ये x axis है, and because यहाँ पे c है, so it means it is a straight line which is not passing through the origin. अगर origin से pass होता तो equation होता y is equal to mx. लेकिन ये y is equal to mx plus c, इसका मतलब that has a intercept on the y axis. Okay, और वो intercept on the y axis is what? c. ठीक है. सो अभी ये दोनों एक्सप्रेशन को अगर हम कंपेयर करेंगे, सो वी गो फॉर अ ग्राफ. ओके, दिस इज द y एक्सिस एंड दिस इज x एक्सिस. सो y इज इक्वल टू 1 अपॉन a माइनस x. ओके, फिर x इज इक्वल टू t, m जिसे हम लोग बोलते हैं स्लोप, दैट इज इक्वल टू k. ओके, आप ये देखिए, आप इसको मैंने इसके साथ कंपेयर किया है. सो x इज t, सो m इज k. And therefore c is 1 upon a. So c का मतलब होता है intercept, obviously on the y axis, so that is 1 upon a. तो x axis में मैं क्या प्लॉट करने वाला हूँ? टाइम. Okay, y axis I'm going to plot as what? 1 upon a minus of x. So I'm going to get a line with the intercept on the y axis. Now my dear friends, there are two types of lines. एक होता है ऐसा increasing line, दूसरा होता है ऐसा डिक्रीजिंग लाइन. टू पॉसिबिलिटीज. नाउ दैट विल डिपेंड अपॉन द साइन ऑफ द स्लोप. अगर स्लोप पॉजिटिव है तो इंक्रीजिंग लाइन, अगर स्लोप नेगेटिव है तो डिक्रीजिंग लाइन. यहां पर आप देख सकते हो द स्लोप m इज इक्वल टू व्हाट? k, पॉजिटिव. ओके, m इज इक्वल टू माइनस के नहीं है, इट इज प्लस के. सो स्लोप पॉजिटिव है और इसलिए वी हैव अ इंटरसेप्ट विच इज इन द फॉर्म ऑफ अ इंक्रीजिंग लाइन यहां पर. तो अगर हम उसका स्लोप निकालेंगे, सो दिस इज अ स्लोप, तो स्लोप इज इक्वल टू के. ओके, और फिर हम इंटरसेप्ट निकालेंगे, दिस इज द इंटरसेप्ट, सो दिस इंटरसेप्ट इज 1 बाई ए. ओके, या फिर इन अदर वर्ड्स वी कैन ऑल्सो से देयरफॉर ए इज इक्वल टू 1 अपॉन इंटरसेप्ट. यानी अगर इंटरसेप्ट का रेसिप्रोकल किया तो यू कम टू नो अबाउट द इनिशियल कॉन्सेंट्रेशन ऑफ द रिएक्टेंट. जब आप स्लोप कैलकुलेट करते हो यू गेट द k value, that is the rate constant. Okay, so this is, my dear friends, the kinetic characteristics of the second order reaction. First one is about units of k. Second, that was an expression about half time, जहाँ पर मैंने बोला है कि half time is inversely proportional to the initial concentration. और तीसरा है ये graphical representation. So I hope कि kinetic characteristics आपको अच्छे से समझ में आ गया होगा.